Hi, in this video I'll show you how to find the equilibrium concentration and the pH for weak bases. So many weak bases do not contain hydroxide anions, and they're not ionic, which means they don't dissociate water and instead they ionize. Now the ionization of weak bases is treated the same way as the ionization of weak acids works. And this time, instead of using Ka, we'll use Kb. Kb, like any other equilibrium constant, is going to be found by using concentration of products to the most power divided by concentration of reactants to the most power. Again, this will only be aqueous because we're dealing with acids and bases. And the larger the Kb, it means the stronger the base. Another thing that, unlike Ka values where we are most of the times given, Kb aren't usually given, but you can find it using Ka, and this is the formula we're going to use. Ka times Kb is equal to Kw. Kw is the equilibrium constant for water, which we learned a few units ago. That is 1.0 times 10 to the negative 14th. So this is basically saying Kb is equal to Kw divided by Ka, which is equal to 1.0 times 10 to the negative 14th divided by Ka. And with that, you can easily find Kb. So let's do a few practice problems. First, they ask the pH of a 0.164 molar aqueous solution of CH3 to NH is 11.980. What is Kb and what is Ka? So first let's write this out. CH3 2 times NH plus H2O will give us CH3 2 NH2 plus OH minus. And this is our base, acid, conjugated acid, and conjugated base. Now to find Kb, we first need to set up our Rice chart. So 0.164 molar is going to be 0, 0, minus x, plus x, plus x. This will be 0.164 minus x is going to be x and x. Now we're given with a pH. This is a pH. And we can find the pOH by subtracting 14 from the pH. So 14 minus 11.980 gives us 2.02. So pOH is equal to 2.02. Again, I use 14 subtracted by this, which gives us 2.02 as the pOH. And now, what is pOH? Concentration of OH minus is equal to 10 to the negative pOH's power. So now we know that pOH, we can easily find the concentration of OH minus, which will be 10 to the negative 2.02's power. Now what is 10 to the power of negative 2.02? It is concentration of OH minus is 9.55 times 10 to the negative 1, 2, 3 times 10 to the negative third. So that is our x value. Since that is the equilibrium concentration for OH. So now we know x is 9.55 times 10 to the negative third. This x will also be 9.55 times 10 to the negative third. This one will also be here. And this one will just be 0.164 minus that number, which will give us 0.154, which will equal to 0.154 molar. This is also molar, and yeah. Now after finding all those, we need to find Kb and Ka. Kb is equal to everything, so x squared divided by 0.164 minus x, and which is equal to 9.55 times 10 to the negative third squared divided by 0.154. And if we plug that into our calculator, 9.55 e to the negative third squared divided by 0.154, we'll get a number as 5.92 times 10 to the negative fourth power. Now with that is Kb. We can find Ka by using Ka times Kb is equal to Kw. So now we're looking for Ka. We can do Ka is equal to 1.0 times 10 to the negative 14th power divided by 5.92 times 10 to the negative 4th power. And if we plug that into calculator, 1.0 e to the negative 14th divided by 5.92 e to the negative 4th will give us an answer of 1.69 times 10 to the negative 11th. This is our Ka and Kb. In our next question, we're given with 0.1 molar solution of C5H5N, and we're asking what is the pH. And now with this, how do we know if it's a strong acid, weak acid, strong base, or weak base? So the thing is, if the formula ends in nitrogen, it's usually a base. And we know this is not one of the strong bases, so we know this is a weak base. And with a weak base, we can set up we can know. And now that we know it's a weak base, we can set up our rice chart. It's going to be C5H5N plus water forms equilibrium with C5H5NH plus OH minus aqueous, liquid, aqueous. Now this, we're given with 0.1 molar initial concentration. Minus x is going to be 0.1 minus x. It's going to be 0 plus x, x, and x. Now to do this, we can find the value of we can find the Kb value by using the Ka value of the conjugated acid. So let's go back to this question. Now this is the base, this is acid, this is a conjugated acid, this is a conjugated base. So first, let's find the Ka value for the conjugated acid, C5H5NH plus. And this will be given by our teacher. And now we know that we're given that this is this number. And how do you find Kb with this number? Well, Kb times Ka is equal to Kw. So to find Kb, we just simply divide 5.59 times 10 to the negative 6 divided by, we just use 1.0 times 10 to the negative 14th divided by 5.59, the Ka, times 10 to the negative 6 to get Kb, which will be 1.0 e to the negative 14th divided by 5.59 e to the negative 6, which will give you 1.79 times 10 to the negative 9. And that is our Kb value. Now with the Kb value, you can use Kb. Now with the Kb value, you can use Kb is equal to x squared divided by 0.1 minus x. These products divided by reactants. And now we can simply plug this into the y equals graph. X squared on top, 0.1 minus x on the bottom, minus 1.79 e to the negative 9th. Go to graph. And we can get x as 1.34 times 10 to the negative 5th. And what is x? X is both our concentration of OH minus and our concentration of our conjugated acid. So now that we know the concentration of our OH minus at equilibrium, we can use POH is equal to negative log of concentration of OH minus, which is the negative log of 1.34 times 10 to the negative 5. Now if we go to negative log of 1.34 e to the negative 5th, we get POH as 4.87. How much sig figs are we supposed to use? We're only supposed to round to 1 sig fig because we were given with 0.1. So it's going to be 4.9 of POH. And if we're going to use 14 minus 4.9, that can give us our pH, which is 9.1. Our final pH is 9.1. Thank you for watching.